I actually don't have a really good intro because usually they steal your thunder and then you're like, yeah, that's what I was going to say. But I'm just Dave. I am the developer Evangelist at Librato, like Joe said. I am here to talk today about alerting, which is a very sort of maligned subject in monitoring in general. And I want to talk about what we do internally at Librato to keep our alerts very effective, because we do have a very effective alerting and monitoring system inside Librato to monitor and alert on things that are happening with our core product, which is Librato. And I also want to talk about the things that you can do to make alerting better in your own environment. So my story today begins in the wee early morning hours of the pre-dawn. You are happily asleep in bed, dreaming, and in your dream, you come across a tree that's growing Tracy Chapman. And you're like, sweet, I love Tracy Chapman. But you're not, like a bad person. You're not going to bogart all the Tracy Chapman. So you pick a small Tracy Chapman for yourself. And you're like, oh my God, you rock, miniature Tracy Chapman. I'm going to transplant you, and we will together spread Tracy Chapman throughout the world, as our dreams typically are. And miniature Tracy Chapman looks down at her guitar in that sort of knowing way that she does, and she begins to sing. But instead of the sultry blues that we all know and love, this horrible combination of buzzing and ringing comes out. And she drops her guitar and starts pummeling you in the face. And it's at this point you sort of realize, wait, I've been dreaming. I'm awake now because something's punching me in the face. I'm fully awake, but I'm still being punched in the face. So what is this? And you sort of struggle in the darkness to open up your eyes, and your cat is sitting on your neck, pummeling you in the face with both hands because your pager's going off and it's making this horrible buzzing and ringing noise. And so you get this sort of rush of adrenaline, like what's going on, like what horrible tragedy has transpired, like who's hurt, why am I being woken up at 3 o'clock or 4 o'clock in the morning because my pager's going off? And so you shoo your cat off your neck, you grope around in the darkness to sort of find your pager, get it unlocked, only to be presented with this. And it takes you a few moments to kind of understand what you're seeing here. But it looks like there's a web balancer that's complaining because of some combination of its back-end nodes has become unresponsive. So now you realize that this is work, and you go a little bit further. You feel a second rush of adrenaline and despair, because it's actually Saturday and you deployed on a Friday night. So what is this? Is this something that I caused? Am I going to be able to figure out what this is? Can I fix this? Is this the first of a deluge of alerts that will eventually signal the death of my infrastructure, and it's because I pushed on a Friday because I thought I was cool like that and everybody told me not to? So you jump out of bed, rip open your laptop, you start to check on the data that you have at your disposal. But everything looks normal. Everything in front of the balancer looks normal. Everything in back of the balancer, as far as you can tell from the data, looks normal. So you start to SSH in to the balancer directly to see if you can figure out what's going on here when you get a recovery notification from your alerting system. So yeah, never mind. It's 4:30 in the morning, and you're like, are you kidding me? My heart is beating in my chest. I'm wired, I'm angry, I'm wide awake. My alarm will go off in 2.5 hours. There's no way I'm going to get back to bed and get any sort of meaningful sleep. My day is literally ruined, and I'm not officially awake yet. So the first point I want to make here is that alerts are really expensive. They are not cheap. They disrupt productivity, they hurt people, and they disrupt productivity. I'll stay there because let's face it. If we've studied at the Gene Kim School of DevOps, we know there are 4 basic types of productivity, and that among these, make the business case, unplanned work is absolutely the most maligned. It's basically toxic. It disrupts literally every other kind of work. It causes good people undue grief. If it were a font, it would be Comic Sans. And so if we could take unplanned work and somehow instantiate it if we could physically manifest it into being and forge it into a bullet and then load that unplanned work bullet into a cannon and fire it at people, that's basically what we're doing with alerting. We're packaging up something, we're packaging up this horrible thing, unplanned work, and then we're giving it to people as if it's our gift to the world, as if alerts are something that people want, which is just, yes, it's a compound, ridiculous notion in so many ways. So maybe we should make alerting more expensive. Maybe if we were able to tax the ammunition, we could slow down the deluge, right? And this turns out to be a pretty good idea if we take a little bit of time to increase the cost of individual alerts. We can not only make our alerts more effective, but we can also reduce the number that we send. And one way to do this is to make what we call a runbook URL. So at Librato, this is one of the things we do as part of the process of building software. We make runbooks in Markdown, and we commit them to GitHub. They contain like some rudimentary information about the service that you're being alerted on. They include firefighting info, design info, links to things like graphs and dashboards of the notification or of the metrics that cause the notification to occur. So to start with some policy enforcement, some very light policy enforcement, it turns out, we can reduce the number of alerts we send. And if you're looking for a good quick fix to have a meaningful impact on your alert quality, this is a really great place to start. 1 second, sorry. But how do we actually fix this? How do we make notifications not just palatable, but effective? So let's back up and consider our motivation for a minute. What are we trying to accomplish that's important enough to invade people's lives? Why do we monitor? And I think for most of us in engineering, this is very simple. We have a thing that we care about. Just like any other engineering discipline where this thing might be something very sophisticated like a satellite or even something organic like a human heart. But whatever this thing is that we care about, the problem is it has to interact with the real world. And therefore we can't fully control what happens to it. It will eventually be exposed to things that we can't anticipate. So, being engineers, we use engineering as a means of getting a steady stream of feedback from the things that we care about so that we can be sure that they're operating within operational boundaries that we expect, right? We might think this thing should never beat faster than 160 times a minute. Or we might think that this thing should never, its altitude should never fall below 80,000 feet. And then we designed the system itself to provide us the feedback we need to detect when those limits are reached. So that's everywhere else but here. I think that if we go back to the alert that we got at 4 o'clock in the morning, the first mistake we made here was that we misidentified the thing that we care about. In web operations, we care about websites. We care about user experience. We don't typically care about balancers. And yet somehow this individual balancer has become the focus of all of our monitoring efforts and the reason that we must be jarred out of bed in the middle of the night. The second problem is that we've chosen a silly metric for this thing we don't care about with host availability. There might be 11 billion ephemeral server instances behind this balancer. We literally don't know from this alert. But we're saying if 34% of them go down, that all productivity must be ceased and my cat has to be sort of interrupted in his sleep. So I suspect that metrics like these are chosen for us. When I see a metric like this, I think to myself, well, here's a metric that I didn't choose. Because it's not the sort of thing I would have chosen. Even if I'm running a balancer as a service company, even if this is the core of my business, this is not a metric that measures how well I balance. So I'd rather know something like the ratio of back-end instances that I'm sending traffic to, because that's a thing I care about, right? As a balancer, as a service person, hypothetically. I/O per host metric is something that I can use as a threshold in an alert to notify people on, because I can legitimately say if percent I/O per host goes above 0.2, then stuff is probably going sideways here, and I need to look at my stuff. So this was not only a horrible choice of the thing I care about, but also a terrible choice of a metric for the thing that I don't care about. And then to top it all off, instead of designing the thing we don't care about to provide feedback for this useless metric, we've tasked an external computer to sort of check in with it every once in a while and then punch us in the face whenever the thing crosses a threshold. And like I said earlier, as far as I know, this approach is unique to our field. This is not what other engineers do. This is like a bunch of aerospace engineers designing a sketchy instrument panel that only updated every 5 minutes, and then paying some kid from down the street to check in every so often on it. If you can't read that, it says Mick Dashboard. Pretty proud of that drawing. Anyway, but aerospace engineers are doing something very different from what we do today. And that's what makes that example absurd in your mind, because aerospace engineers are reasoning about the limitations of the thing they build, and then they're instrumenting the thing. They're designing, engineering the thing to provide them the feedback that they need directly to their operators in as real a time as possible. So this thing that we do that we call monitoring is not the same as what other engineers in other disciplines are calling monitoring, is my point. And that's a problem, because we have this notion that monitoring is something distinct from our other engineering pursuits, that building the things we care about belongs to team A, and that monitoring things in general belongs to team B. And this causes really derpy and silly feedback loops in really sort of counterintuitive ways. So I think to the extent that we can reintegrate monitoring into our other engineering pursuits, into our day-to-day engineering activities, and we carefully choose metrics that tell us about the things that we care about, that give us the feedback we need, our alerting will improve in kind with our telemetry signal. So, if you think I'm dreaming about that, I have the dry mouth speaker thing, by the way. Sorry, I usually the water. Oh, look, there's a water shelf. Cool. All right. So if you think I'm dreaming about this whole reintegrating the monitoring with the rest of engineering, I want to take us a couple minutes here and talk about what a bad day looks like inside Librato. So a couple months ago, this happened. You can tell it's a bad day, by the way, because there's lots of flame emoji and lightning bolts. If it's a really bad day, there's poop. But what we're looking at here is we got 2 notifications from a Campfire chatbot. We're a chat ops shop, so when we get notifications like these in group chat. The first one of these says that our API is throwing an exception because it's not able to queue a data point. The second one says that one of our RDS instances has too many persistent connections. So it's literally telling new clients to go away. It's saying, hey, I have 360 persistent connections. I can't make any more. Sorry. And when you're an engineer, I think it's very natural for you to envision the pieces of the thing that you care about when you see a problem like this, or at least the subset of the thing that you care about that's relevant to the problem that you're seeing. And in this instance, we have this blob of JSON that's incoming, that's gotten itself lodged in the API. And simultaneously, we have an RDS that's unresponsive. If you don't, RDS, by the way, is AWS for MySQL. Well, I think they do Postgres too now. But it's a database, relational database system, excuse me, that's not responding. And we can't help but ask ourselves, do these problems correlate? Does one of these things depend on the other? And it turns out that yes, very early on, the API interacts with this RDS instance to do a name to UID translation. So the problem here is that the API is unable to persist this data point because this RDS has become unresponsive. It can't make this name to UID translation. It can't cache that data point, queue that data point, excuse me. So this intuitive leap that we've just made together, this imagining of the pieces and their interaction with each other in the context of the problem is pretty much what happens in the head of any engineer who knows this system and sees this problem. These alerts form in our minds a common cognitive model and a common understanding of what this problem means. And that's probably the most important difference between these alerts and the ones that I got at 4 o'clock in the morning in the chat room. The former trigger in my head a notion of how the things that I care about are threatened in real life, and the latter do not. My alerts imbue me with a desire for specific follow-up information. To what extent are my users affected by this? Is it backing up the SLB? How many of my unicorns are specifically blocked right now waiting for this RDS instance? Are the RDS read replicas blocked? Because if they aren't, maybe we can point the API at a read replica to keep this ship from syncing. So the next thing that we see in the chat room, rather than heading for the SSH terminals to sort of answer these questions, we see that our ops chief, Peter, has put some graphs in the war room for us. So we head over there, and what we see is that various other engineers in the organization have already begun to fill in these gaps in our mental model, because we have a common vision of this problem. So we share the same questions in our minds, and we can answer them collaboratively by sharing telemetry data with each other. So yes, this is affecting end users because we see this huge dip in HTTP 200 traffic. Yes, it's backing up the SLB because we see this huge latency spike there. All of the unicorns are literally blocking in the API, and the read replicas aren't going to save us because this problem is actually affecting their ability to replicate, and therefore they're unresponsive as well. So, as the problem persists, our engineers ask more and more questions, and each of their questions is answered by telemetry data, and each of those answers begs more questions, which sends them back to the telemetry data, until they reach a place where they can take some meaningful action. And in this particular instance, I'm going to stop there, but in this particular instance, we wound up rolling back a deployment that introduced sort of a derpy API query to a third-party API vendor. But you can read this story on our blog. I think there's a link to it later on. So my point is that at Librato, this is what problem solving looks like literally every single time. I know I have Evangelist in my title, and I'm therefore prone to hyperbole. But I assure you, this is exactly what it looks like. Is this not what it looks like? Libratid teens? What are we calling ourselves this week? I don't know. This is what it looks like. We get notifications of real trouble. We rely on the same telemetry data that triggered those notifications to solve our problems. And we can do this because we know what we care about, and because we've instrumented those things to provide us the feedback we need, the visibility we need to solve those problems. So when we build a thing like a worker process that's going to consume some input from another service and then queue the rest, as engineers, we inevitably wind up codifying a set of assumptions, operational boundaries within which my worker is going to be happy, just like the things that other engineers work on that shouldn't beat more than 160 times a minute and should never fall below 80,000 feet, sorry, whatever it is. My worker has needs, right? It might require that service C, the cookie service, respond with a 99th percentile latency below X. It might require that this queue that I'm working with never exceeds K elements. So whenever our process depends on assumptions like these, whenever we identify things that threaten the things that we care about, we build in instrumentation to measure and report these metrics to a common upstream metrics repository. We need to own this choice. No one can make it for us. We can't assign a team to commit to a tool that's going to influence or even, or dictate or even influence our metrics decisions. We need to choose them for ourselves. We internally empower and expect that everyone is going to measure the things that we care about in the best possible way. And we make it really easy to store the results of those measurements together, because monitoring is literally everyone's responsibility who builds a thing we care about inside Librato, be it infrastructure or applications. We have, I think what my CTO Joe sometimes calls a show me the data culture. Whenever we make a statement about production behavior, whenever we point a finger at something in production, we have the data to back it up. So our metrics data naturally becomes part of every conversation that refers to some sort of questionable production behavior. In this way, our data guides our intuition because we really don't have a choice. The metrics are there. Everyone knows they're there. Everyone knows how they work, and there's no fooling them, right? Telemetry data is anathema to speculation. It confirms our assumptions, or it discredits them utterly, which is hard sometimes for human beings, But I don't think that any of us would trade it for the world, because this telemetry stream we have, it's like this ever-present rock that we can stand on when we're struggling to understand the behavior of ephemeral entities in production. Whether we're dealing with issues, or we're designing new services, or we're shipping features, this telemetry stream tells us, without a doubt, what's happening right now in production. And if it doesn't, we fix it. So our metrics are very dear to us, which is a very fundamental difference between the way we monitor and between the way a lot of other shops monitor in the wild today. We value and we nurture our metric choices. We share them with each other in the form of prized insight, like you see here. And when we add new ones, we do so very deliberately, because they teach us something that we didn't already know about the things that we care about in the wild. So we don't get alerts about silly metrics because we very intentionally don't record silly metrics. It sounds a lot easier than it actually is, but it's true. So for us, monitoring isn't a separate activity anymore. It's literally just a part of correctly building the things that we care about every day. We improve it, we iterate it, right along with the code that we make and the services and infrastructure that we build. Everyone does it, and we all benefit. And of course, yes, we still track system metrics. We use collectd internally to record things like CPU utilization and memory. But when we send notifications, when we alert, when we wake people up in the middle of the night, our notifications always trigger about the things we care about. And they always trigger when the things we care about hit limitations that threaten them. So these are always things like latency, queue sizes. In this example, it's the rate of data I/O between two services. When our notifications are delivered, they get delivered into group chat, where they don't jarringly interrupt anyone's workflow, and where we can talk about them in a group context. This is a huge win for us because it eliminates redundant effort. Everyone can react to the alert together rather than individually reacting to the alert along with their cats. If our alerts aren't critical, they'll stay here until somebody gets to them. If they are critical, they're escalated using a service that enforces an agreed upon on-call schedule that everybody pretty much knows about. If they escalate, we require them to be acknowledged, and we also require runbook URLs and links to things like graphs of the metric that triggered them. So I wanted to make the point that we're able to include a live link to a graph that a metric just triggered, if that makes sense, because we're using the same input signal for both alerting and visualization. If you use disparate signals, if you are today monitoring and you have one system that polls and notifies and another system that records and visualizes, then you invite alerts that don't correlate with your metric data. And this is absolutely one of the best ways to undermine the credibility of all the systems involved. If I get an alert in the middle of the night and my data doesn't agree with it, I don't know which one to trust. And so I wind up eventually trusting neither. We wouldn't design, for example, an EKG this way. We'd want one signal that was as reliable as possible, and then we'd build systems on top of that signal. So, and building a reliable signal is hard. It's not easy, but building a reliable telemetry signal is orders of magnitude easier than making two disparate monitoring signals agree with each other in every case. I would argue that that's actually approaching an impossible problem. You'll never make them sync. So you either need to replace them, or you need to find a way to sort of unify your signal. This situation where my data doesn't agree with my notification should never happen by definition, because my data should trigger my notification. So another thing I couldn't show you from that chat room history is that our alerts are created and maintained by the people who receive them, which is also a fundamental difference from the way that most people monitor. So not only do we rely on everyone to choose and collect the metrics about things that we care about for themselves, we also empower them to take ownership of the way that feedback is presented and used to trigger alerts. This makes sense because not only because the people who build the things we care about are absolutely the most qualified to interpret feedback from them. So every time we see red in a dashboard, every time we get paged in the middle of the night, those alerts need to refer to data that the recipient is intimately familiar with. Every alert I get should document behavior that violates my personal notion of healthy for the system that I designed, for the thing that I care about. It should trigger in my mind a cognitive model for how the thing I care about is threatened. If it doesn't, if it just tells me some overly specific information about a disk somewhere that may or may not be threatening to the thing I care about, I should delete it immediately. So once you have a good telemetry stream, absolutely, put the cannon in the hands of the people who it's aimed at, I guess. It's victims, because they will help you fix it. They're incentivized to help you fix it. They're incentivized to make it fire less because they're in its crosshairs. So I hope you've enjoyed our time together as much as I have. And I'll leave you with the following ultimate recap slide, which will be relevant in video later. And for my next trick, I will now create a short period of awkward silence before self-consciously returning to my beer.
Great. Anyone have any questions for Dave? Questions, queries, comments? Going over here. On the other side. Sorry. So you just described the use case where you had this stack where each one of those components were instrumented in delivering appropriate telemetry data. Now, you learned a use case where that sequence failed and delivered inappropriate results to the customer. Is there some way in which, as the organization learns those scenarios, that can be codified instead of everybody having to continue to research each one and build sort of a in your mind heuristic? I mean, can you start to think about sort of a meta level assessment where you're stitching all those sequences together in some sort of other problem?
So it's hard to talk about this stuff in general without knowing, like, are we talking sort of operation side or development side? Yeah. So operation side is a little bit more difficult because the people who receive the alerts don't typically design the system originally, right? But to the extent that you are DevOpsing, I hate to say the word out loud, but sort of if you're familiar with the process, the second way talks about shortening the feedback loop between your engineering teams, right? So the concept is basically that you have people who are making things and they need to know how those things are operating in real life. And another team may be in charge of actually getting them that feedback. And sort of management layer, DevOps, right, classical style, is to make that feedback loop as short as possible. And that typically involves removing things like permissions, bureaucratic roadblocks between, right, like point A and point B, and making it so that people can directly affect change in the systems that you're using to the extent that that's possible. So you shouldn't be asking yourself, how do I better document the way that these alerts I'm getting don't apply to me? You should be asking yourself, how can I make it so that the alerts I'm getting that don't apply to me have a delete button that I can push to delete them, right? Like, you're looking for ways to, in as close or in as safe a way as possible, put the cannon in the hands of the people that it's being fired at, right? Does that kind of answer your question?
Yeah. You're hitting at parts of it.
Are you getting at like anomaly detection?
Well, no, it just seems like you go through all this analysis to come up with this insight, and yes, you need that direct feedback, that short feedback. But at the end of the day, the experiences in the organization, and it can't necessarily be codified until you're able to stitch all those together. So you still have, if it came up again, those people weren't on staff, you would go through the same exercise one more time, right? There would be no way to actually codify.
Actually, Etsy's done some interesting stuff there. I think they've released a couple tools with regards to postmortems and I think like alert responses. I don't remember the name of the tools, but they're going to be able to get over those. So like that.
But that seems to be just a more codified version of something you talked about in terms of basically people sharing what useful alerts there are, right? So you demonstrated one example of that, of just two people sort of apparently chatting together. The step between that and actually documenting, here are some useful alerts that you pretty much anybody should consider, is a relatively short, small one, right? And it's not, and I would argue that it does not in any way sort of take the cannon out of the hands of the people who it's aimed. It's just a bunch of suggestions from other people who've done it.
Yeah, I mean, runbooks are a living thing, just like metrics are, just like alerts are. And a lot of times these situations, if there are lots of intersecting things, generally speaking, you either attempt to actually fix it so they can't intersect that way again, or if you can't and it is reproducible, then you design an alert and run work specifically for that situation, so you don't have to connect the dots next time, I would say. Right. So, any other questions? So we have, our next meetup actually is going to be regularly scheduled, so it's in December. Nick, what's the exact date?
Good question.
Oh, okay. We're still saying it. It's going to be in December. It's going to be Rackspace's office across downtown. So just keep your eyes on the meetup page for that. And then the videos for this, like I said, we posted on the Librato blog probably within a couple days. And I think we notify the meetup group too when they go out. So thanks everybody again for coming. It's great having you, and make sure you take some pizza for the road.